Alright, it's time to get started. Here goes nothing. Sorry I am a little late today. So, this is our next step in the road. We have completed the CPU, we have created unit tests for almost every single instruction, and we have tested most of them. And wait, what did I do wrong? I did not change anything, I think. So it's failing jump subroutine absolute, and that could be because a break now affects the stack. That makes sense. So I just wonder why it didn't fail before. And it happens since I changed the CPU. So the break instruction where is it? Probably on the top. It will call NES break instead of quit, as it was in the parent class, and now it is pushing the flags and the program counter. So what I am going to do in this assertion is bar push it. Hey Cricket, you are on time today. How are you doing? So this was pushed processor flags integer equals to CPU stack pop 8 and pushed program counter, and it's an integer equals to stack pop 16. I am putting an underscore in here because it's a variable that will be unused, and this underscore helps to tell Godot to not generate a warning. So now that we are popping the flags and the program counter, this assertion should be correct because it's getting the next popping. So let's try it, and it has worked, but this other is another case where the same process will help. So we are just fixing some unit tests now that we changed break. And this other also makes the same assertion when popping values. So let's paste the same. Okay, this one seems to have failed. And why is that? Okay, so push processor this is loading 0, and this is setting this bit flag, and this is pushing the flags to the stack. And and this is pushing this other value, and when you pop it you will get first the processor, then the program counter, then this value in theory, and then this value in theory. So if it is not this value, then what is it? Let's find out. run it. And A is 181. Let's open our calculator. And in programmer mode, we see that 181 is the binary 1011 1010. So, and what is push at processor flag? Oh wait, it is the same value. That's interesting. Did I do something wrong? Is the order correct? The order in which I am pushing? So it makes sense to match, because in theory I did not change the processor flags. So that sounds about right. So question is, why is this not what I expected it to be? So the flags that we have in here are 0 is set, and these are the break flags, both set. Negative is set. So this should not be 0. So why did I expect this? Alright, so 78 is set in a flag. So this was negative and no 0. So this should be 0 here. It should be 0 here. And before pushing, when I push it in here, it should push it without the break flags. So why is it the same value before and after? It should change before pushing the processor flags on break. Wait, now I get it. So because I am pushing these two flags as ones. So that is the issue. So these two flags are now 1 always when pushing. So it's P and P2 flags are always pushed as 1. So those are the break flags. So that is the issue. So they are always pushed as ones, and they are always pulled as ones. And the only case where B, which is this flag, is set to 0 is when it comes from an interrupt and not from something that I call from assembler. So I need to undo some stuff. Okay, so now it is like it was before. I am going to change the values of the flags to 1 all at the same time. Flags are pushed as 1. And let's give it a shot. And now it passed, and this is exactly the same case. So it's these two flags, if I am not wrong. Oops. Okay, I messed it up. Bum bum. I'm missing a 0 here, and we'll copy the comment. B and B1 flags are always pushed as 1. And what did I do wrong? So if I say this is negative, why I am not expecting it to be negative? So what is it? CPU plus, and we have break is set, break 2 is set as expected, negative is unset, C is set, the carry flag, 0 is set. That's strange. So it seems too much. Maybe I messed up the position of this number. Binary numbers are weird. So assertion failed, and that is because the stack pointer advanced by 2. So I need to paste the same lines that I have copied in here. And put it before every comparison, before every assertion. Why is it complaining? Oh, I see. So this variable already exists, so it cannot be registered again, and does not need to be typed again. Okay, awesome. Same situation here, because we are comparing to the stack pointer. Let's run. Okay, and now everything is passing again. So we have fixed our unit tests that now was breaking because we changed the break command. So let's commit that. What happened to the music? Find our console. Git status. Lot things changed. Git add in part. Yes, we added some values. We set flags that are always changed when pushing. Git commit fix unit test that was failing because of break, because oh no, if of break opcode, now pushing processor flags and program counter to the stack. Git push origin main, and now I can once again focus on the current task. So let's move on. So great, you have made it this far. What are you going to do next is to take a bit of a detour. The snake game was introduced in this article, which is not what. Oh yes, so this is an article that shows how assembler for the 6502 works, and it has a JavaScript version of a compiler, and has a mapping in the memory that can print different values and colors in a square based on some memory mapping. So maybe at the end there is the entire snake game like this, and if you assemble and run it, you will see that you should be able to change to run the game. Okay, it uses WASD instead of the arrows. Okay, so this is the snake game running in the 6502 processor, but not in an NES. This is a much simpler piece of hardware, for saying so. So awesome. And however, it's a fun way to validate that our CPU is truly functional. It is fun to play the first game. The majority of logic we are to implement now would be reused some way or another when we will be implemented rendering in the PPU, so nothing is wasted effort. This is the machine code for the game. So we are going to create a test snake class or test snake scene. So the testness. So let's test snake 6502 and a new scene, test snake 6502, and let's I will make it a control for now. Change type control, because I am used to controls, and I am going to add a script. Wait, I forgot to remove the template. Well, it doesn't matter. Extends node for now. I will change it later. And we are going to create a variable, or better yet, a constant, game code of type packet byte array, and it is going to be equal to this array. So we got the code, the machine code in Godot, and we are ready to load it into our CPU. So let's continue with the tutorial, one step at a time. You can find assembly code comments here. I hope I don't need them. The majority mapping that the game uses, the memory mapping, sorry, 0x000A is the random number generator, so that means I have to assign a random number every frame into this value, I suppose. I am making the assumption we are going to get new, more detailed information soon. FF is the input, a code of the last pressed button. Each cell represents the color of a pixel in a 32 by 32 matrix. The matrix starts from the top left corner, so from this location, so this is 200 and continues in 221. F and 220 to 223F, and that is how the memory mapping seems to work, and every different values works like a code. So there is a color code table, and we are going to get it, or is probably the same color code table as shown in this example. Maybe it's not explained because of that. Let's find the part of the list of the colors. Register and flags, instructions, branching, addressing modes, that's it, indirect, the stack, jumping, creating again. So there was some part explaining how to set colors. So this is setting some colors, but I wonder where is the color list. Explain it. So it does not seem to have a list written. So we are going to need to find out ourselves. We are getting there sometime. So important note, the game expects that the execution code will be located right after the output expression. This means that we need to update our CPU load function. Okay, so that sounds like we need to make a subclass of the NES CPU and change what is the starting point. So we are going to make a class snake 6502 CPU extends NES CPU, and we are going to override func load. Can I see the parent? Func load. Okay, this is the signature. Awesome. And let's copy what we had, because we are going to need to do something similar, because Rust uses this syntax to copy, but we need to iterate the array and write it. So this time we are starting on 600 instead of 8000. So let's change that. And this is the right location, and seems about right. So the game's executed standard game loop: create input from the user, compute game state, render game step to screen, repeat. We need to intercept this cycle to get user input into the input mapping space and render the state of the screen. Let's modify our CPU run cycle. So let's see, what does it do? Run with callback. What? I don't know how to read this. So function mutable CPU. So, and it is going to run callback first and then match the code. So now the client can provide a fallback that will be executed before every opcode interpretation cycle. Yes. That sounds about right. The sketch of the main method. So it creates the new the CPU, load the game code, reset, and run with callback. And with it did not specify a callback. Well, we have a much simpler way to do it in Godot. We can choose create a virtual method that is executed every frame. So we can just make in our run while it is running, just call a function PC advanced. And this happens before or after okay, it happens after advancing the PC, right? No, it does not seem to. It happens before, because this is where the obtaining of the program counter is going to happen. Hey, Els, how are you doing? Nice to see you. We are in middle of finding out how to inject the input and the rendering into our CPU for the Snake game. So what the Rust implementation is suggesting is that we have a function pointer that is executed every time before a new instruction is executed in the loop. So we have two ways to do it. One way is using a virtual function. Another way is emitting a signal. Another way is creating a virtual function, and if needed, emit a signal inside that function. So let's find out what we need to do. So I think we are going first with the virtual method, and it's a method that is internal, and I think it should exist in our parent class. So as a rule, virtual functions or internal methods starts with underscore. So we are going to make about to execute instruction pass virtual. Implemented on each CPU as needed, and this function is run into our core loop right before advancing in the program counter. So now we can implement about to execute instruction and do whatever we need here. So this is a virtual override. I hope I wish I understood more of this side of the NES. Well, it's probably a good place to do it. So this is the big table that says how things works. So you have most probably seen how uh, it's Roland. Yes, Roland programs. He uses these commands and some magic numbers next to them, right? So the thing is, depending on how the next number rating next to the command are written, this and this ADC, this ASL, they are converted into a different number that represents how the memory is going to be addressed or treated, but it makes exactly the same operation. It just changes the way that the arguments are obtained from memory. So ASL is arithmetic shift left, and it can and when you specify the register A, it will use this command, and when you specify some memory that is on the first uh, on the first slots of the memory, so it takes only 1 byte to get the memory. It uses this command. When you have more than 1 byte to specify the memory, it uses this other command, and so on and so forth. So the way that I have done it is I have used a function that executes the logic, and I just pass some argument that says how to get that memory. So this is called addressing mode, and it is how to get to the memory. So for this code, it goes to the register. So I don't know how much you know of the NES CPU, but the NES has three 8-bit registers, which is the accumulator, the X and the Y register. And this is the accumulator. It's the one that where most of the mathematical operations are done. And this other happens directly on memory. So that means the byte that it reads, it is find that memory location and perform the byte shifting inside that memory. Zero page means the location in the first 256 or something like that, which is an 8-bit number, a byte number. Zero page X, it means that number plus X, whatever is stored on X. Absolute is take 2 bytes, so it and takes the entire memory mapping from 0 to quadruple FF. and absolute x is takes 2 bytes and also add x to those 2 bytes and then find the memory address. But the operation is always the same. It's arithmetic shift left. So there is no need to make the same function a lot of times to make it work. We are only changing how to identify the memory where the execution is being made, right? So this I closed it. So let's find it again. And I don't want to have this visible in streams. This is the list of all instructions. So it's 5 by 3, 6, 9, 12, 14, 5 by 14. Sorry about this. It's embarrassing. So 70 instructions, and each one of those instructions will have 1 to 7, I think, variants uh, related to the addressing modes. A lot of them does not take all those variations. The more complex does. That is what we have been working on up until this point. We created all the functions to register every single variant of these numbers that the machine code will execute. We register it. We are going to execute this function. We are going to pass these arguments when this is found, and it's a huge list. And then we have all the list. So this is the code that gets the memory where stuff is happening for the different addressing modes. See, immediate means just get whatever is the next byte. Do not try to look at the memory. Just take the value. So it's like making a +5. You don't want to addition the contents of the memory location 5. You just want to addition 5. Zero page is read the memory from whatever the value is. Absolute is take 2 bytes from the next values on the program. Zero page X is take 1 byte and addition the contents of the X register, and so on and so forth. So we have completed this. This is the part of the code that makes every single operation. So we have add with carry for a register and addressing mode. We have bitwise and with a register. We have arithmetic shift left, arithmetic shift right. We have no operation. The most simple of all is just do nothing. Inclusive or exclusive or pushing values to the stack. I don't know if you have a concept of what is the stack, but it is used to share informations when jumping to a subroutine or something like that. So it's a way to have some part of code that can be reused. You should push values to a to a I want to make the analogy of a stack, but how can I make it? Pi.net. So this is going to be embarrassing because you are an artist, but I use Pi.net. Sorry about that. So imagine this is the floor, and you are going to make a stack of information in here. So you are going to put a value here, which is a 5, a value here, which is a 10, and then you jump to a subroutine. And when you jump, that subroutine is going to remove this from the stack and remove this other one from the stack, and we'll use them, and we'll push the result of whatever it calculated to the stack before returning back to the previous state of the program, and that the code that will continue executed will pull from the stack this value to know what is the result. That is more or less it works. It is not the perfect analogy. Some of this, the instructions or the order of the stuff that I have said may not be accurate because there is more stuff happening on the stack when making branching and jumping, because there are other things added to the stack, and in the middle of the process, and I don't even know how it works, to be honest. I did not investigate deeply on it. I just implemented the instructions as I found described on on the on the reference. So I have this kind of description. Let's find stack, something related to the stack. So jump to a subroutine. It says pushes the address -1. So that the address, I suppose, is the current point where the execution is happening. So you have a list of instructions like this one, and you have a position of what is executing. You can imagine that as the caret of the keyboard. So you have a caret of what is the current location. So the location is not the content. The location is from the start how many times it advanced until this position. So don't think of it as the content of the table. Think of it as the call of lines and columns of the text processor, to give you an analogy. So that is the position of the program. So it pushes that, and then sets the program counter to whatever is the new status. So you are in this position and you are going to jump to somewhere else, let's say to this. So it pushes this value into the stack and then changes the current position to an arbitrary or other position. And then when you are returning from that subroutine, it will pull that old position and will restore it and advance it by one, and it will continue executing. That is, in short, how the jumping works. I am fading and I am out of the stream again. Sorry. Oh, so are you having connection issues? Oh, even I am having connection issues. I just got reconnected to the chat. That is not good. Anyway, I hope this explanation works for, it helps for someone. If not in here, that maybe it's someone that looks the video after. This is just the code that Roland writes, transformed into machine code that will be interpreted by an NES emulator. I always have trouble watching this one. I will have to lurk with my PC since my phone can't seem to get the job done. Well, that is a shame, to be honest. Um, mm, I don't know. I wish this worked better. Maybe it has to do with the region I am streaming from. Maybe it has to do with my ESP's provider. Uh, all I can say is I always record the sessions and I always upload it to YouTube afterwards. Maybe it may take a couple of weeks until I sit down and clean up the video and upload it. but I think I have the first 7 streams uploaded already, or something like that. And this is stream 9, if I am not wrong. Um, anyway, um, I hope you could get anything from from what I have explained so far. So we now have a way um, to implement um, so Nelesai says I am watching without any problem. That's nice to know. Where are you from? And did I read your nickname correctly? Nelesai. And what's that, a bomb? So, yeah, it works fine from my PC, not from the phone. Hmm. I am from Argentina. My name is Nelson. Well, Nelson, that I am from Argentina as well. Bienvenido al stream. Que te sea grato escuchar un poco de Rosario Gacino. It's Nelson plus science. Makes sense. Raw science. Yeah, I am up in the States, so I think there might be an issue with it somehow. But it only happens with this stream. That is strange. So anyway, so let's try to focus and move on. Um, so because now we have injected our function to be executed before every instruction is run, we did it on run and we are about to execute instruction. We can make a new implementation of that function in our Snake CPU. So now we can find out what does um, the tutorial suggests us to do with this new callback. So yes, thanks Els. I am working on an NES emulator. Uh, I am using Godot. I love Godot. I use it for working. And this emulator is for ROM's NES games. Have you? Do you identify which one is it? This is Nintendo Entertainment, right? Not Family. So it is what we in Argentina call the family. Uh, we used to call it the family console, not the NES or the Nintendo family system. We should call it a family. And this console, and it plays games like the classic Super Mario Brothers. So ideally, when the time comes, we will be able to play this game in our emulator. Hopefully. So let's continue moving on. Pa-pa-pam. Moving on. Read user input and write it into memory FF. Update mem FE with new random number. So every instruction FE changes by a random number. So that's good to know. So we can say memory memWrite, and we are going to update OXFE, which is the location of the random number. and we are going to use the randy range, and we can range from 0 to 0xff, which is the maximum value we can have in a range. And let me see if that 2 is inclusive or not. Yes, it is inclusive. Awesome. So we have done half of the job. The other half of the job is updating the input. So to update um, the the code of the input, we need to find out what is the code that um, that this game is expecting to read, right? So this part of the tutorial is saying how they are setting up SDL to reading the input. We don't need to do that job. Um, so we can choose uh, find out uh, mm, we just need to find out how to get the right value to inject into this memory. So we know that we can so what is set is the last some ID of the last button registered. So let's have a variable last button pressed and make it an int, and we are inserting it into the memory location ff for the input, and last button pressed. So we can choose, like, from the side of this class, this is a node and this is a subclass inside that node. And in our real node, we are going to have an instance of the snake CPU. And we can have a function input event if event is input event action, and event is pressed. We can set the last button preset of our CPU to whatever we like. So we can say CPU dot last button preset equals magic. So for now, we also need to make we can match event dot action get action. So how do I get the name of the action? Pa-pa-pam. Okay, it's just action. Event does action. So I can say if it is UI up, so we set the CPU to something. If it is UI down, this is maps that automatically exist in Godot in every new project. We set the last button preset to something else, or so on and so forth. So maybe this is if event preset, then we make this, and if it is not preset, and we say if action in a list of these possible stuff, Then we say CPU. I am missing a semicolon here. Last. So this is if, not is. I am making stupid mistakes. Last button preset equals 0. Nothing is being pressed. So I think this is more or less the idea. I think this can be even improved. So this is event.action, not action. This is a way to do it. The other way to do it could be creating an input map in here. Const input map, and this is going to be a dictionary. And this dictionary is of type string name integer. So we are going to have a string name like this, and an integer that is associated with it. Let's take a random number for now. And I can fill up this list with all the inputs that I am concerned about. So I can take UI up, UI down, and left and right. I think Snake only takes those 4. Oh, right. So I just need to find out what is the number that this is expecting. And if you'll go to project settings, and go to the input map, you will see nothing. And that is because this is like to add new inputs, but if you check show built-in actions, it will show everything that comes bundled with Godot. So we have accept, we have select, we have cancel, and you can see that we have input to do stuff both from the keyboard and from a joystick. So UI up is going to take the D-pad up from a joystick, and also the up button, the up arrow from the keyboard. And if I like, I could add another key, which is something I am do actually. And I will press W, and I hit OK. And now I can press W for moving up, and I can add another one and press S for down, and I can search UI right and press D, and UI left and press A, and now I have WASD to move in the snake cursor. In theory, I should not be doing this because I am making a plugin, but I will keep it for now, just for fun. And the thing is, what is the values that we want to be using? So main is creating an SDL context for the window, starting a video stream, creating a video, center it on the screen, creating a canvas for drawing the UI, setting a scale. So 1 pixel is actually 10 pixels. And 32 by 32 matrix will become a 320 by 320 screen, which is what is setting as the value, as the size of this window in here. So next we will create a texture that will be used for rendering. So it is working on rendering before the input. So here, this is what I was looking for. This is what is used for every key press. So it is handle user input. It is passing the CPU and the event. And when pressing escape, I suppose, it is exiting the process. And when pressing down, it uses this value. So for UI down, we are going to set this value. Wait, sorry. So this is W. So W is up. This is S. This is down. Okay. This is A, which means it's left. And this is T, means it's right. And this is what it is. So now that we have our input map, we can say, instead of checking a match one by one, we can say, if not event dot action in CPU dot input map dot keys, just return. So we only care of actions that happens in the key. So if the event is pressed, we are going to set the button, the last button pressed, to whatever is the action in the action map. So that is the CPU input map, and access the event action member of it. So if it is not pressed, we should set it to 0. We already checked that the action is in the list that we care. So this is all, famous last words. So we have our input worked. And I could, or I should, also accept the input. How was it? It was get viewport handle is input handled, set input as handled. So this is the way you accept an input and prevent it from propagating. So stop the input from propagating further down in the scene tree. So that is how you avoid when you press the W that something else catches the W and executes something else. Okay, so awesome. We have the part of the that is handling the input executed. So first we need to initialize STL. It is creating a window. It is creating a canvas. Into canvas, present the scene, will blah blah blah. And we don't care of that. We can I have to find out what does this use to identify when it is needed to update the texture. So let's try to read a little more step by step. We add the cargo. We need to initialize STL. This looks correct. We have a canvas to draw and an event pump to pull keyboard inputs from. It set the scale on the canvas. So it is a 32 by 32 texture. Next, we will create a texture that will be used for rendering. So creator is a texture creator, create texture target, and it is creating a 24 bits uh, texture with 32 by 32 size. We are telling SDL that the texture has this size and each pixel is to be represented by 3 bytes R, G, and B. So it means no alpha. This means that the texture will be represented by 32 by 32 by 3 array of bytes. Okay. Handling user input is straightforward, and we have already done this. Oh, we did. No, okay, so we did this part where do not handle the empty one. Rendering the screen state is a bit trickier. Our program assumes 1 byte per pixel, while SDL expects 3 bytes. From the game point of view, it doesn't matter much how we map colors. The only two colors maps that are essential are 0 black and 1 white. But we have uh, a couple more colors in this list. So let's try uh, to make this same function in our CPU. So the CPU sounds like the right place to turn uh, a byte to color. So let's call it that. This is a virtual function byte to color. It takes a byte of type integer and returns a color. So we are going to match p byte, and I will paste it in here and remove some indentation. Whoa, uh, stupid Steam. Oops. So this is the list of values we want to test. So Rust uses the OR. In GdScript, we use a comma and a list. And now we have to change this to something we can read in Godot. So this is semicolon and return, and it's color dot black, right? So this seems to be valid. This is of course not valid. So let's fix it all at the same time. And to do that, I'm going to hold Alt and put many carets with the mouse and start pressing Ctrl Delete to delete the parts that we don't want. And now I will put a semicolon, new line, return, space, move with Ctrl right one step, delete 2 times and add dot. And now I have valid values for all of those cases. And I am also missing to remove the comma. So maximum keyboard use for here, and the underscore means any other case we'll use cn, and we don't use curly brackets, and this sounds about the end. and return. So gray is not a color, maybe gray with an A. That's strange. So it says not a cases return code, so we can, oh, it's return here. And now it works. So that was a little tricky. Uh, it was not, probably not properly explained, but it is what it is, right? So yay, so we are updating and our random number generator, updating our input, and I don't know if in this instruction we should also update the rendering. Now we can transform the CPU screen into a map like this. Color index, read this value, and get the color from the color index. A caveat is that with this is that we don't want to force updating SDL canvas if the screen state hasn't changed. Remember that the CPU will call our callback after each instruction, and most of the time those instructions have nothing to do with the screen, right? Meanwhile, updating the canvas is a heavy operation. We can keep track of the screen state by creating a temp buffer that will be populated from screen state. Only in the case of screen changes, we would update the SDL canvas. So yeah, so we can make a function to render uh, the state. Let's make a function uh, render screen, and make it in a way that we can call it any moment that we like. So for this, let's create something that could be fun or not. Let's find a knob texture somewhere. Let's say open game art. Let's put some music. The music have disappeared, and I want the music back. Pa-pa-pam. Why is it not showing the... Wait a second. Oh, okay. So here we go. Back to the start of the playlist. Anyway, so let's find a rect knob. Wait a second. Rect knob. Nothing. Pixel. Block. Something like this could work, so it looks more fun. Tile pack. Doesn't sound like this is layered. I want something that is white. Oh, we have a snake here. So I don't want to make it too complex either. So this could work, or this could work. This one sounds about right, except it is blue. So if I get the SVG, I can try to open it with the Inkscape. Okay. Load from downloads. Maybe. Not here. Where are downloads? Okay, here is the box. So we can try to see the feeling. Okay, and it uses this gradient, so we can turn this into white and this into gray, and save it now. And now we have a gray box instead of a white box, and we can drop it in our test program. So I will find it here. I will put it inside the asset and rename it to pixel. So if I double click it, I see that it is created as 200 by 200. That is a little too much. So I can go to import and change the maximum value to something different, like 128 by 128. Sorry, it's 128, not multiply. So I can re-import, and now it is 128 by 128. And the idea is I can make this test snake into something different, like a grid container, and I can make it have 32 columns, and put make it full screen and add this pixel texture like a texture rect, and it has that default size. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and we only have 9, so that means that 128 is too big, right? So let's try something much smaller, like 32 pixels, and re-import it. And now it's taking 3, 6, 9. I can actually use the name of the screen to find out if it is correct, and it exactly matches 32 pixels wide in my screen right now. So I could do it like that. It's a way to do it, but this is going to be a square, meaning this will be like not in the right resolution. So what is the right way to go? Let's see. Maybe we change the window resolution. We can also make a new window and put the make this the root. And we can set the size into this window to be 320 by 320. And now that we want each pixel to be 10 by 10 pixels. And we also want the separation to be 0 in this grid. So we can change the constants to have 0 separation. And I still think 320 by 320 is too small. Let's make it twice the size. And maybe once more. That's a little too big. Okay, let's go with 640 by 640 for now. And let's make this pixel 20 by 20. And now we have it like perfectly matching, right? Or at least that's the idea. And we can take all these 32 pixels and duplicate them together. And now take all these 64 pixels and duplicate them together. Now we take all these 128 pixels and duplicate them together. And we take all of these, so it is becoming a little faster every time. And now we have the screen filled with the squares. And what we can do is for every square we have one KB of pixels, and for every one of them we can set in the visibility what color it is going to be shown, right? So we can make it a kind of blue, or a kind of red, or a kind of yellow or cyan, and we can make it on individual colors, individual pixels, visibility, and change it only for this pixel, make it different. And that is how we are going to do this, right? So that is the idea of how we are going to update this. So we have this window, it has a size. Let's make the limit of the same size, so it cannot be resized. And let's change some flags. So let's say it is visible, yes, why not? Transient, exclusive, no. Unresizable, yes. Borderless, no, I want to be able to move it. Always on top, no. Unfocusable, okay, sounds like this is unresizable is all I wanted. So if I hit play, this will not show this screen because it will run my unit test again. So now we have to change the project. So when I run, I will run the snake test instead. So I can hit play and it will open two windows. It is opening this window and the other one inside of it. It's a little weird, but it's because of how I created it. I made it like a separate window, but it is embedded inside the other one. To fix that, I have to go to the project and search embed and now I can disable embedded windows, and now it will create two windows, one for the main application and another one for the Snake game. So I also want to change the initial position to the primary screen center, and it will appear on the center of the screen now. Oh, but my primary window is the other one, so maybe main window is screen center. Okay, and now it appears in here, and I can change this title for Snake Game 6502, and now I have that in my representation. So now that I have this, I can use these pixels nodes to update my rendering. So let's see how the tutorial navigates the pixels. It is making an iteration from this memory to this memory location. So instead of that, I will use an index for E. Oops, it's for, not fear. For E in range, and the size of my range is 0x600 minus 0x200, and this is the size of the memory mapping that I want to iterate, right? And address is going to be I plus 0x0200, which is the first memory dedicated to the screen rendering. So now I can get the color from the CPU, bar color index integer, this is also an integer, equals CPU dot memory dot read, and we are getting it from our address. And now bar pixel of type color equals CPU dot byte to color, and pass the color index. Oops. And now I can say get child and pass the index of my child, and that is why I have this I index and not counting internal. And I can say modulate wait a second. Okay, so let's say bar pixel texture equals get child as texture rect, and now I can say pixel texture modulate, no, self modulate equals pixel. And I like typing, so let's make it a texture rect here. Okay, so now I have these functions that effectively reads the memory and sets the modulate of our textures in the screen. So in theory, I could run process. Oops. And process will run every frame, and I can render the screen in my process. And when I start, everything should be set to black, because black is the default value. 0 is black and it's the default value. And we are currently not running the game, so we could start running the game on ready. CPU.load, and we pass our program, the game code, and CPU reset, the same as in Ross example, and CPU.run. I could also have executed load and run. With the game code, but my concern is that this will not interrupt. This will run forever and never advance, never exit this, and not keep time to render again, because this is not running in a thread. So maybe let's make a new thread. So let's first try to run it and confirm it will stall without showing anything, as I expect, because it will never exit from here. Okay, it seems to have tried to do something. Did it run? Okay, advance. Okay, it seems to have executed in only one frame and finished it in one frame. So what is happening there? So instead of making assumptions, let's see how it is handled in the root side in the tutorial. And I am convinced that this is more or less accurate. So frame index, okay. Frame index +3. And why is that? What is frame index used for? It's used for the frame memory. So the frame memory is the subdivision of the memory, and that is because they can make direct access to the array, and I am just getting read value. So colon index, color index RGB, and frame ID. So it is setting. Okay, so frame is the texture, maybe. What is frame exactly? I don't see what frame is. Okay, frame is an array of unsigned integers. So they are just creating an array. So let's see how this screen state is used. Like, so run with callback, and in the callback it will handle the input, will write a random number, and then will read the screen state, and if it changes it will update the texture passing the new array, and then copy the content and presenting it into the window, and it is making a sleep every single time after an instruction. The last sleep statement was added to slow things down so that the game runs at a playable pace. And there you have it, the first game running in our emulator. So, what we seem to be failing at is that render screen should be happening inside this callback, and there seems to be a sleep happening in the middle. So load and run game seems to be correct for saying so. Question, should that be happening inside a thread? Should that be happening? How? So in the callback that is being executed, which is this callback about to execute instruction, it is making a sleep. How do I make a sleep here? So only functions. That doesn't sound right. Okay, seems like I don't have sleep exposed. So I would use a timer, I guess. So for that, I would need to make this an async function. So I can await, create timer, no, get tree, no, I cannot get the tree from there. Create timer, okay. And we can set some time, like, I don't know what is this value. I suppose this is in milliseconds, maybe. But let's see. Choose a 10 frames per second and see how it works. And this means we have to await for about to execute. So let's see if we can await about to execute. Let's see if this runs still. And I think I am still doing something wrong because I am creating the timer, but I did not specify the signal timeout. Print frame. Engine, get process frames. Let's try to give it a shot, and it seems to be running still, but we don't see anything updating. So let's put a breakpoint and see what is happening here. So what is inside pixel for every pixel? It is always black. So if color index not equal 0, we are going to print the pixel. So let's see, are we getting any value that is not a 0? It seems not. So nothing seems to be executing. So let's find out what is going wrong. So let's load and run our game code and see what happens. Let's go from the start. We are pressing load the program, and it is entering our snake program, and it is writing on this memory address. And let's put a breakpoint after all these and execute and see what is the memory of the CPU. So if we peek into the memory, like here, we should have starting in 600 0x600, which is, let's see our calculator. It's decimal 1536. 1005. Wait, what? Uh, 78. Okay, and previous screen, and in 1036, which is what I found here, it should have the first byte of the game code, which is at 22 decimal is 32, so it is effectively a 32. And so this is, it seems it should be running, and let's see, maybe maybe the timer that I set is too much, because it is not a per frame waiting. It is not 10 frames per second, it's 10 instructions per second. So the 10 instructions per second is very low. It is going to take a huge amount of time to execute. So let's try to make something like this and see how it behaves now. So it made 64 frames and ended, and it never changed the screen. So that did not help. Maybe the timer is too small. Hey, timer value is too low. Do you think so? So this is, as I was saying, this is not per frame, this is per instruction. This is a pause that is happening every time this code advances once. So in theory, this code runs 60 frames per second, but that is not 16 instructions. It is actually much more instructions. So we don't have an interrupt right now, right? So we need to find a way to tell the game if it is or not time to do an advance. So let's do this. Bar frame start int, and let's make it equals to 0. So let's say frame start is going to be equal to OS get time or get system time. How is it to get the system? I think you can try to count time using OS time functions. Yes, that is exactly what I was going to try. Let's find time. Oh, it's time. It was moved to time. Or is this just conversion? Let's find the OS class. OS should be... Okay, I did not find the OS class, so I suppose it is indeed time. And we have a global scope time. Yes, we are in Godot 4. Okay, so that explains it. Thank you. Time get... Do you have a system? Get time dictionary from system. Get Unix time from system. And we want it on milliseconds? I don't think so. So if bar delta time equals time get Unix time from system, and this is a function, minus frame start. If delta time is bigger than 1 divided by 60, we are going to make 60 frames per second. We are going to await 1 divided by 60. And print the frame. So this is more or less the idea. And we also want to set the frame start again. And see if this runs, I guess. Okay, it have run until frame 80 and then stop it. So the game is ending apparently. So we seem to be doing something wrong. So how do we debug this? Music stopped again. Any ideas? Is a wait happening? Like, can I change this for 3 seconds? And it prints every 3 seconds. Okay, it seems so. So yes, we have a good frame duration. So we can have a const frame duration equals this value. So we can change it to whatever we like we can make it 20 frames per second. But it doesn't sound like this is correct either, right? Because we are waiting one fraction of a second and waiting another fraction of that second, and get ticks millisecond or get ticks e second. That can also work. Right, because frame is an integer and the time is a float, right? The Unix time. No, it's an integer as well. Okay, so that doesn't really matter. To the end, it is the same. So the thing is, we basically need a way to make this work in parallel, like advance some steps and render, and advance some steps and render. This is making a sleep every time, every instruction of this value that I don't know what it is. So I can find what is the signature of duration new, and 5 seconds. So it's 5 seconds and 5 nanoseconds. So the second argument is in nanoseconds. Nanoseconds, 2 seconds. Oh, can you show me it in a more useful way? 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this one is a nanosecond. This is stupid math. So it takes 70,000 nanoseconds. And how much time is that in seconds? So we can make it like this. Okay, so it's like 0 dot and a 7 in here. 1, 2, 3, 4, 5, 6, 7, 8. Like this. It's the 7, 1, 2, 3, 4, 5, 6, 7, 8, and then the point. I think this is the time, but it's probably too small to be executed in an await. But let's see if this kind of works. So we are going to await every time it executes. And does not seem to have created any effect. So we can try stuff like printing the program counter. Is a register, right? Oh, right, we are the CPU. There is no way to use CPU. So program counter has been advancing, and from one frame to the other, else print don't sleep, and let's see how much it works. Okay, it is always sleeping apparently, so delta time is always bigger than this value. Okay, so I think I have an idea of what is happening or not. No, because I am awaiting this function. So I am reading the wrong memory address. Can I make a pause after some frames? And I am in frame 52 and see what is inside the CPU in this moment, like what is in memory. So the thing is, wait a second. Okay, so it is using the 0 page apparently. And what about what I am wondering is if maybe I am reading the wrong address for the screen. Like, let's check that. I think I did it correctly, but I could be wrong. So read the screen state 200 02 00 to 0600, and it is reading that memory. And what do we have in that memory addresses? So it's decimal 512. So let's find that. Wait a second. Did I see? I saw a value. And this is probably the input, maybe? I don't think so. I did not input anything. 254. 254. And it's FE. So FE is the random number generator. Okay. So that is not weird. We set it for every instruction, we regenerate it again. Buenas noches, Coria. ¿Cómo estás? So we are a little blocked in here. We are trying to find out how to render, or why is the game not running as we expect. So we have some values, 504 and 504 is 1F8 hex value. What is in our memory mapping 1F8? Let's find out here. It does not seem to be anything. It is just auxiliary memory, maybe from the game. So this does not seem to be working as expected. So maybe what I can try to do is comment is running equals false in the break, and it will execute, it will continue running. For more frames. See, so now it continues and the program counter is in some sort of loop. We can still not see anything. But the game is looping now, at least. So why is memory never changing? I don't yet know, and it's hard to think how this will execute. So I wonder what this break used for in this code. But they did not bother too much into this tutorial to manage the timing of the CPU. They should put a sleep for every instruction. What if I change this black to something else, like a red? Is this updating? Yes. So it is indeed reading the values from this. But where is the actual rendering happening in our CPU? And pa-pam. So it is always sleeping. Right, this is now ticks. Okay, so this is milliseconds, right? Milli or micro? Milliseconds. So 1 second is 1000. So this is 1000 divided by 20. So how about now? Okay, now we have some frame skips. And that sounds more likely. Okay. Let's say when we are actually not doing anything here. We are always waiting a timeout. This is just useless. It's like just for having a print from time to time. So we can print, in example, the input equals and put the last button pressed and see if it is registered in the code of our WASD. And no, it is never changing the WASD. So what is input doing here? Right, because now we are a control and we cannot use input, so we have to use GUI. Right, so I have to use control, so I can use the GUI input event, and let's see if it accepts keyboard events. Okay, no, it is not accepting them. Never. And does input work? No, it is not taking any input either. So there was a variant of input for the keyboard events. So what is it? Input. I just want to go to the top, please. Blah blah. I want the function names. GUI input. Do I have to grab focus to get the keyboard input? Shortcut context. That's new. Okay, we have mouse, we have focus, mode none. I could change it to off. Yeah, it's still not registering any input at all. Wait, I did not put a breakpoint. What is it? So event is an event, choose not an action event. Okay. So it registers inputs, but they are not action inputs. So I have to parse it. Input event key equals input event action dot new action event dot parse. Wait, or is it input parse input event? What does this do? No, it's not what I want. I want to convert something into an action. Wait. This is the opposite. It turns an action into a different kind of event. It creates it injects the event. So if I search input event action, it's the only usage I find. Yes. Okay, so I guess I will have to do it differently and say for action in the input map, if event is action, and then if pressed do this, if not pressed do that, and there we go. So okay, we got we got an error, and we actually got into this check. So now we can set the button preset. So now we are getting some input finally, and that is good. Llegaron visitas. Ok. Fue tu saludo inicial, no lo había registrado. So the game loop is running, but we seem to be rendering from the wrong place, or the game seems to not be setting the values that we expect. So color index is always 0. Could my math be wrong here? So we want to iterate from this to this. And we go from 0 to value it's one entire kilobyte. I put a breakpoint. Let's comment this. So we get a little less stuff. And when is this even changing? So we can try to assert or to make a change. So we can say if address bigger or equal to 0x200 and address lesser than 0x600, breakpoint. So are we ever getting to this point, making a change? It does not seem to. So the game seems to be running without changing that address value. So what happens if I try to choose print address and value? This is crazy. Because it will flood the entire output, but will give us an idea of how usually it is to access a memory address. So it seems to always be using the 0 page. So how do I convert an integer into a hex? What if I search for hex? I'll search it from string, hex to int is valid hex number, hex encode, hex to int. I want integer as hex. So I need to find Python format integer as hex. And it's blah blah blah. This is not what I want. This is probably what I want. Now I have this and this. I try to print. Okay, and now it prints as hex values. This is quite fast, but not all of them are 0 page. But none of them is happening in the what is supposed to be the screen position. So there is a load of FF and FE. So if address, so if not address in OX, FE, OXFF, because those are the ones that we write every single time with a random number and with the input. So we want to not print that. And we only print the changes that are made by the game code. So we are making changes in 0 page, in the second page, but never in the OX200 to OX600. So are we mistaken of what is the range of the screen? So it's OX200 to OX600 and it's the output. And this seems to be correct, but the game is never setting it. Does that mean that our CPU is wrong? So it doesn't feel like this is wrong. So we are following the instruction here. So I wonder what part of this code sets the value. It's impossible to try to know it, but we can see the assembly code in here and see if it is commented. So we have screen location of apple started as 2 bytes. What? Oh, the apple and the snake. The snake body in byte 5. I suppose 0 terminated. So what is being set in there? Nick Morgan's blah blah blah. The screen is divided in 8 strips of 8 by 32 pixels. Each strip is installed in a page, having their own most significant byte. Each page is 256 bytes, starting at 00 and ending at FF. So, what does this mean? I don't quite understand the meaning of this. 0x000 to 0x000FF, 3 to FF, 4 to FF, in the snake, generate apple position, return loop init init the snake, initial snake direction, store value of register A into this address, and this is a literal to snake length in bytes. Generate apple position, so generate apple position is going to load a random number from FE. So loop read case, check collision, update the snake, draw apple, and draw snake. And spin wheels. So we can see what draw apple and draw snake does. Check collision, check apple collision. Load the first memory address into register A, compare to 10. Branch if not equal, position change it, so don't check in collision. So it's comparing the position of the head with the position of the apple. So what I want to see is how does the draw work. Update the snake, load the value stored in the snake length into register X, and decrement X and transfer to A. Update loop. So this is how 0 page X is written. Text decrement X and set negative flag. If value becomes negative, up, up, right, down, 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 left. Collision is game over. Draw apple. So draw apple is going to load a 0 into the Y register, load the random value into A, STA difference the address stored. Oh, so this is indirect Y. Okay. That's interesting. So Y was 0 from this. So I think this is like an indirect without Y, I guess. So A is the position of the head. And what was STA? STA is store accumulator. So it's basically save the value of the accumulator into this memory. Okay, it is storing the random number into the memory being pointed at 0, 0. Draw snake. Load 0 into X, load 1 into A, store A into the location differenced by 10 plus X, X is 0. Load X and whatever is on 3. 3 is the length of the snake. Set the value of the register to 0. And store memory address, storage address, and store the value of A in the resulting address. So basically, load 0 in X register. Okay, spin wheel is just making no operations for some time. So, what did we learn? We learned that on checking Apple collisions, generate Apple position, checking Apple collisions, shutdown, check snake collision, snake collision loop, and this will start iterating 10x and compare and continue collision loop. Right, so So it is checking if the head equals to any of the snake body parts. Maybe collided. Did collide. Branch equals did collide. Continue collision loop is this. Increment X register 2 times because it's 2 bytes per body segment. So X is the body part, and then it is comparing X to the length, and if it equals the length, that means that it did not find a collision. Snake collision log. Did collide, jump to game over, didn't collide, return. So the thing is, I never find a moment where the color is set. I don't find any rendering code in this. The game is running, it's just not being rendered. So we have some values, but we don't seem to have anything saying, okay, this should be copied from this to that to there. So I am not sure of what I am doing wrong here, or what the tutorial is not covering. Rendering the screen state is a bit trickier. Our program assumes 1 byte per pixel, while SDL expects 3 bytes. From the game point of view, it doesn't matter how much we map color, we only need 2 color maps that are essential. So we have a byte. And where is color ever used? It's color index RGB B1, B2 and B3. The caveat with this is that we don't want to force updating SDL canvas if the screen state hasn't changed yet. Remember that the CPU will call our callback after each instruction. Also, time to instruction has nothing to do with the screen. Meanwhile, updating the canvas is a heavy operation. You can keep track of the screen state by creating a temp buffer that will be populated from the screen state. Only in case the screen changes, we would update the SDL canvas. So yes, I can also do it like this, but so this is going from 0x300 to 0x600, and I am doing the same, right? I am reading in the test snake. I am reading from 0 plus 2x000. So I can try to make this same print. Where is this print happening? Oh, it was on the memory. So I can comment this, and I can copy this. And I can come here and print it in this stupid loop. and print I and color index. And see what happens now. This will be a stupidly big print. So I could try and make it to print equals string to print plus equal, and this if I mod 20 equals 0, I can say I plus 1, so it doesn't insert it on the first line. To print plus equal new line, and after everything happened, print to print. And let's see, what do we find now? Let's pause the game and see what is the output now. So I just want the first frame. Let's go again. I just want the first frame. It's a very long print. Copy, and let's see in code. Wait a second. It did never add a new line? Okay, it created 3FF. So what happened with the other half? Wait a second, maybe this is like this. Did something change now? Copy from here and paste. Okay, now we have something different, and we see that it goes from from 0 0 to this. So okay, so yes, we need to print I plus, so we need to print address, not color, not I. Let's give it another shot, and now it looks a little more familiar. Actually, I could even make it module 32, and this would be like a screen capture in bytes. Copy. No, that was not copy. Pants. Copy. Now I can come here and paste it, and now I have my screenshot, and it works exactly like what was supposed to look like according to the documentation. It simply never changes any value, so maybe maybe let's try to do this can I get a slice of a packet byte array? Yes, I can have a slice. Okay, that is useful. So I can take slice, and I will copy this, and I will go to memory, and I will add my own func slice. Yes, I will not put a default value. If end equals -1, let's use that. And equals what was it? Memory dot size. So end is going to be memory size. It should be size or size -1. Probably size -1. Return memory slice begin end. So now I can more effectively check if I need or not to update the screen. So I can do something like bar last frame last screen buffer packet byte array equals empty. So now in process I can say bar screen buffer of type packet byte array equals CPU memory slice, and give a begin and an end. So I can give a 0x000 and an end of 0x0600. If last screen buffer not equal screen buffer, last screen buffer equals screen buffer, and we render the screen. And now we are, instead of reading the memory directly, we are going to use this screen buffer variable dot size. So we don't care of the address, we just get the coloring directly from the screen buffer. So it would be I plus OX200. Now it will execute the first time, giving us an empty screen as before, and if we continue, it should never change again, because it's never changing that memory address, the memory in that address, right? So this is emulating more or simulating more what is happening in the tutorial. We are getting a slice of the memory, and if it changes, we are re-rendering the screen, but only if it changes. And in their case, they do this for every process, for every step, not in process, but for every instruction. So they do it like this. Put it inside this instruction. Right, so now last screen buffer becomes a member of the CPU. And now I assume we need a signal. So now instead of render screen, we emit the signal. And now we can connect in 3D. CPU screen changed, connect to render screen, and render screen now takes the screen buffer. Packet byte array, and now we use screen buffer instead of last screen buffer. Let's see how that goes. Yes, it changed once and never again. So this is even more similar to what happens in the tutorial, but the code of the game is seems to never be setting the value the values in that memory range. So if we go back to memory and increment this, we can run some time and it will run a couple and give it a pause and see what are the values that are changing. All the values that are changing start from 01. And we know that we have some idea of where the snake is and where the apple is. I have paused it there, but I can also continue and wait here. And now we are on the memory itself, right on the memory itself, and we can see some stuff from the assembler. We can see that in the location 00 and 01 is the location of the apple, so we can see that the apple is located at X. Wait, this is decimal 102. It's hex CA, and I suppose it's CA and 3. It's just a 3, so it should be 03 CA. If I look at the memory 08 03 CA 3CA is the decimal location 970, and if I go to that location, no, too far away, 970, and there is nothing there. So the snake is not being rendered. I mean, the apple is not being rendered. The game is running, but it's not being rendered. So the thing is, why is not it being rendered? What happens if I see the draw apple? What does it do? Draw apple. Loads 0, loads a random number, stores indirect Y, it makes a deferred. So it is storing a random number inside STAE. So STA indirect Y 91. So let's see OX91. Do we have an OX91? In our game code? Sorry. So here is the 0x91, and if we look at the assembler, it takes effectively a 0, which is the next byte. The next byte is 60, which should be return RTS. Return. So yes, this is indeed the storing of the memory. So why is it never running? We can try to see that in our CPU. We can try to store from register and say if p addressing mode equals addressing mode indirect y breakpoint. Okay, so do we ever call this function? Okay, let's remove this, and the other breakpoint has never run. So what does that mean? What happens if I remove the break from this? Like if it didn't exist, does that change anything? Is breaking something? Okay. It stopped after a couple of cycles, and that is because it's running is being set to false. So let's try to do the opposite. Let's keep it, but let's choose return without doing anything with the stack. Does this change anything? So it seems to be repeating some cycle stuff. It's repeating something over and over. And if I pause and find any breakpoint, this is an example, and if I see the CPU, and the memory, I can pick the memory, and it says that the apple is in 4200, but of course 4200 is not being drawn because draw apple is never being called. So this is what the loop looks like. One is, so maybe what is failing are the jumps. This one be jumping to read case. Read case is loading FF and is comparing to different opcodes. And in case of equals, it is entering a subroutine. Def key, down key, right key. So 1 is up, 2 is down, so it makes a comparison with the opposite direction, and if that happens, it is an invalid move. That makes sense. Illegal move will just return. Jump subroutine. So I can check if jump subroutine and return subroutine are working, but I'm going to do that in the next stream because this has gone too far along. So it's been frustrating, but it has been an interesting experience until now. So thank you so much for watching, and we will continue next time. We will find this out. Cheers!